Memory operations are simple and reasonably symmetrical. There are two major classes of memory operations, those which increment their address and those which don't increment their address. For the non-incrementing fetches and stores, you may use A or B as the address. Fetch and store use A as the address and move to and from T, as do all the rest of these operators. Fetch B and store B use the B register as the address and move the data to and from T. Incrementation applies in fetch plus and store plus, which use A as the address source, and also apply to fetch P and store P. The plus is omitted for brevity and compactness of code, but fetch P fetches and post increments register P, and store P stores and post increments register P. The incrementation is aware of where the address is coming from, and its behavior depends upon what address space you're accessing. If, as we indicated before, you're in RAM, the incrementation wraps at 7F and goes back to 0 so that you stay within RAM. If the address is in ROM, the incrementation wraps around from FF to 80 hex so that you stay within ROM. And a very special feature of our computers is that if the address is in I/O space, generally speaking, you're going to be talking about a COM port or something that behaves like a COM port. The instructions are being executed as a stream through a port, through a memory map port, if you will. In that case, incrementation would be of no benefit. And so in that case, the incrementing operators, when used, simply omit the incrementation. Thus, if you are accessing an I/O port, COM port, fetch and fetch plus behave identically. Store and store plus behave identically. And fetch P and store P do not increment, so long as the value in P is within the I/O space. This is an incredibly potent and powerful capability, as we'll see later.